And here it is, my magnum opus. You have a 3-stage vacuum tube amplifier right here, and it uses my favorite 6J5 triode. If you need a triode that'll do general amplification and is reliable, there's nothing quite to beat the 6J5. Do not touch any pins. As you can see, I use 1930s brass screw construction. That provides the filament. Literally, the wall power comes directly from the wall after a half-wave rectifier. And this is the relays that convert direct into alternating, amplify the alternating, and then convert it back to direct. And the feedback resistors of those two, the filter cap there, is what's on the rectifier side, and these are just for stability. This function generator here is what's timing the relays. So the gain is 5. So for instance, if we turn this one, which is your input voltmeter, all the way down to a -1, and it takes a second to get it there, 99, it's really close. We can see on the analog -1 scale here, 12 volt scale from the knob, it's almost exactly at 5, which would be that tick right there. We can do other values. For instance, -0.5 volt. Alright. That's pretty close. Would give us 2.25. Or 2.5, ideally. And it's pretty close, 2 and then some. Almost exactly 2.5. That one there's 3 on the 12 scale. Okay, we can also do larger values. Well, 0 zeros it, as you can see. A little bit of back bias. And let's increase this thing. Let's go all the way up to, well, 3 volts would be off the scale. Let's do 2. And you can get really precise with it. That's pretty close. 2 volts times 5 would give you 10 volts, which you can see right there is what it gives. It works. It amplifies direct currents. One final one would be 1.5. What would that give us? 1.5 would give us around 7, I think. 7.5. And as you can see, 7 is right here, and it's just 6 and 8, just over it. It's not entirely accurate. I've used 5% components or 10%, but it works. It amplifies direct currents. Now, as you see, when you change the input up or down, there's actually a delay caused by the rectifier cap trying to discharge to the right value. Well, 0.2 would give us 1 volt, wouldn't it? 0.19. And you can see we wait and it moves, and when it stops moving is when it's equilibrated. Okay, this is 0.25, which would give us 1 1/4. 0.25, 0.2, close enough. It's almost 1 volt, 0.8 or something. And it's not quite accurate, but it works. Amplifies direct currents. And so it goes from DC to AC, amplify the AC, rectify the AC, back to DC with the feedback, and there you go. So I think this is a pretty interesting circuit. When you turn it to 0, it goes to 0. Let's see one more value. Let's say we had 3. Let's see if it'll give us 15. I think it will. My money's on it giving 15. Oh, well, it only goes up to -2.24. And that's off the scale. The battery is weak. Ah, shucks. Let's just try let's just do 0.75 and see what that gives us. That's pretty close, 0.74. And that would give us, we get 0.75 is 3/4. Give us 15 quarters, which would be just under 4 by 0.25. So it would give us 3.75, and this one gives us 3.5, roughly. Well, as you can see, my supply battery's dying, so it's not completely accurate. But this is it. This is the vacuum tube amplifier, and as you can see, it gets capacitively coupled in. That's the grid. Ground is the bottom ones. The filaments, these two, cathode. The next one, you can see it goes from plate, capacitor, next grid. That's your grid leak right there. 770 ohm or 35 kilo ohm. We're close. Cap out, cap in. Self-bias resistor network is here. And these guys get awfully hot, awfully fast. This one here is just roasting. I used a lower resistor to get him the right impedance. Anyways, that's it. An op-amp made entirely from vacuum tubes, and it works, approximately. But I imagine if you could use more precision parts and tubes that weren't 60, 70 years old, it could do a lot better. But this is the proof of concept.